Hi guys, today's lesson is on 3.8, which is finding and estimating square roots. I'm going to try and use the Elmo today to see if this works. There's going to be 4 learning targets today, and I'll go through each one of them. Before I get to the first one, square roots. If you look at this diagram here, the square root of 16 is 4 and negative 4. The reason is 4 squared is equal to 16. But negative 4 in parentheses is also equal to 16 because negative 4 times negative 4 is 16. So when you ask for the square root of 16, there's actually 2 answers, 4 and negative 4. You can write it 4 and negative 4 like this. Or another way of writing it, a shortcut way, is putting plus or minus 4 that way. Okay. Most people eventually you're going to end up writing it this way, plus or minus 4 when you start dealing with square roots. Okay. Learning target number 1, when they ask you to simplify a square root expression, okay, simplifying a square root expression, they're only asking for the positive or the principal square root or whatever they ask for. So in this case, it'll say simplify each expression. When they ask you to simplify it, they're just asking you what is the square root of 64 or radical 64, that equals to 8. This sign is also called the radical symbol or the square root sign. Okay, so I can say square root of 64 or radical 64. That equals to 8. In this case, it's negative square root of 100, so it's negative 10. Okay, it's like an operation, square root of 100, so 10. And you just drop that negative in front of it. In this case, plus or minus, the square root of 9 over 16 is equal to plus or minus 3 over 4. Square root of 9 is 3, square root of 16 is 4. And if you think about it, 3/4, if I squared it, 3 times 3 is 9, and 4 times 4 is 16. Okay? For D, plus or minus the square root of 0 is just 0 because there's no such thing as positive or negative 0. It's just 0. Okay? And for E, if you notice the difference between B and E, in this case, the negative is outside of the square root. In this case, the negative is inside of the square root. So this is negative 10. In this case, the square root of negative 16 is undefined. There's no real solution. There's no number times itself that will equal to negative 16. Negative 4 times negative 4 becomes positive 16. The only way you can get negative 16 is a positive 4 times a negative 4. And that's not itself because one is positive, one is negative. So anytime you have a negative number under the radical, it's going to be undefined or no real solution. Learning target number 2 is going to be rational and irrational and telling the difference between rational and irrational square roots. Okay. If you remember before when I was telling you the difference between rational and irrational numbers, one of the irrational numbers was square roots that were not perfect square. If it was a perfect square such as 81, the square root is 9, it was a rational number. Okay. The square root of 1.44 is 1.2. So negative radical 1.44 is negative 1.2. Okay? But 5 is not a perfect square. So you can see the negative radical 5 is going to be irrational. If you look at the square root of 4 over 9, that equals to 2 over 3, that is rational. Some of the rational numbers, as a reminder, fractions, if it can be written as a fraction, it is rational. Or a terminating or ending decimal, that is also rational. Okay. This could be written as 0.6 repeating. Again, a repeating decimal is also rational. Okay. It's the ones that don't end and don't repeat. That's the irrational number. Okay. And you can see this is a perfect square, 4 and 9 is a perfect square, so that kind of helps too. If you look at this, 1 is a perfect square, but 3 is not. So the square root of 1/3 will just continue on and it won't terminate and it won't repeat. Therefore, it's an irrational number. So that's how you tell the difference between rational and irrational numbers. If it's a perfect square, it's going to be rational. If it's not a perfect square, it's going to be irrational. Be careful with the fractions. Both numbers have to be perfect squares. Okay, so here's some examples that they give. Radical 8 is irrational because that's not a perfect square. But radical 225 is rational because you should know square root of 225 is 15. Good. Okay, number 3, learning target number 3, estimating square roots. Okay, And the way the book will ask it is, between what two consecutive integers is a square root? So for example, they give you between what two consecutive integers is the square root of 14.52. And what you want to do is you look for the perfect square that's either right above it or right below it. So in this case, I know a perfect square right next to radical 14 is radical 16 because the square root is 4. The other one to the left of it or less than that, so the number above it is 16, the one below it would be 9. Square root of 9 is 3, square root of 16 is 4. So this number is between 3 and 4. Make sure these two numbers are consecutive, 3 and 4. So if you went to square root of 25, that would be too high because you would end up with a 3 and a 5, and those aren't consecutive. Okay. So an example that they give is between what two consecutive integers is radical 105 or negative radical 105. The way you would do that problem is the same way. I know if it's radical 105, I know that radical 100 is right below it. Okay? And if that's 10, it's kind of a shortcut instead of going both ways. I know that this one would be 11, which is 121. But because of this negative, I have to put a negative 10 and negative 11. So negative radical 105 is between negative 10 and negative 11. And you can see they have the answer here. Okay, so that's how they do those. And that was learning target number 3. Learning target number 4 is using real world problem solving. So giving you a formula and figuring out how to use it. So in this example up here, they give you the formula. D is equal to square root of x squared plus quantity 2x squared. Okay. And they told you find the length of the wire if x is 12 feet. So you need to substitute 12 in for the x's. Okay. So if you look at this, what they did was they substitute the 12 in for the x's. So you can see in red, they have the 12 here, they put the x for 12, and the 12 here. Okay. According to PEMDAS, we got to do this parentheses first before we square it. Okay. So when you go down, you would get 12 squared is 144. 12 times 2 is 24. 24 squared is 576. That's where they got that from. So 24 squared is 576. When you add these together, you get 720. Okay. And then square root of 720, you should know this. If not, you can use a calculator. I'm just joking. Is about 26.8. Okay. So the length would be 26.8 feet. Okay. That's the 3.8, which is, again, finding square roots. Finding and estimating square roots. Those are your 4 learning targets. Here are your 2 homework check problems. Okay, pretty simple ones. So number 1, find the square root of 30 and round it to the nearest hundredth. Okay, so I want you to write square root of 30 equals, and then whatever, use your calculator, but round to the nearest hundredth. Okay, homework check number 2. I have a rectangle. The width is radical 4 meters. The length is radical 9 meters. I want you to find the area, but I want you to show me the work as well. So please have these 2 homework check problems done before you come into class. You can do it on the back of your agenda, or you can do it on your homework before you start the problems. But somewhere, this will be your check. Please show me these before you come into class, or as you come into class before we start class, and that'll be your homework check. 2 simple problems. I hope this helps, and this video is a little bit over 9 minutes, 9 minutes and 20 seconds. Okay, take care, you guys. See you later.